Hello everyone and welcome to new discussion which we are going to have on Google Earth and its applications. In the previous lecture we have discussed about a little bit about Google Moon and Mars, but as you know that the first product which was created was for Google Earth or for the Earth by the Google. So, it is very well known Google Earth. As you know, it is a special product or a special custom designed GIS software which for representation of 3D representation of the Earth basically, and two main data sets have been used there. So, one data set which is a digital elevation model from SRTM, Shuttle Radar Topographic Mission, and that is in the background for elevation values which we see on when we move our cursor. In the bottom right corner we see the elevation values when we choose the terrain option, of course, and top of that you are having satellite images of various resolutions. As you keep zooming it, and when you zoom in you start seeing higher and higher spatial resolution satellite images, and sometimes you can even see the images of 1 meter or even less spatial, less means maybe 30 meter or 30 centimeter or 60 centimeter satellite images there. Of course, these images directly cannot be downloaded, but lot of research work and lot of work can be done using these images, because biggest advantage is that whenever I want to see the things in 3D perspective, I do not have to do anything, just I tilt or rotate and I start seeing things in 3D perspective. So, apart from these two data sets, then we are having many other data sets we can switch on, which are generally point data or line data, like boundaries of the political boundaries of the countries and locations of cities, maybe locations of earthquake epicenters. Many things are there, and users can also add their own data sets, and through these utilities which are available in nowadays in standard softwares like KMLE files are there, and which allows the users to see their own data sets top of Google Earth. Slowly lot of applications have come up which are based completely on the Google Earth. Especially we find Google Earth is very useful like for studying landforms from various angles. And satellite images which I have just mentioned, originally first it started with Landsat images at say 30 meter resolution, and later on high resolution satellite images were also now available or pasted on the Google Earth. So, as you zoom in it comes out. So, it is a kind of a pyramid structure at a very coarse or when you are viewing a large area, then a maximum 30 meter spatial resolution satellite images are seen on the Google Earth, but as soon as you start zooming in, then small area is covered in very high spatial resolution images. And the most important part is lot of data is available, but it is available on your screen or desktop very quickly. That allows us to study things very quickly, search also, and so many other things can be done with Google Earth. Apart from this landform studies, we can also use Google Earth because it has become a sort of standard to georeference our own satellite, high resolution satellite images. Because the coordinates which are available through Google Earth can be used to georeference or find out the common GCPs, ground control points, in our input images, and then georeferencing can be done. And once the georeferencing has been done, then we can send or paste these our georeference images on the Google Earth and can see whether the georeferencing has been accurate or not, because in the Google Earth you are having continuous images for entire globe. So that way it is also very, very important. This is how various screenshots of Google Earth there. You know, it's a very small utility. You first you have to download and install your machine. Data is not on your machine. That's the, I would say, beauty of Google Earth. Only that small program is on your machine, so it doesn't occupy much space of your hard disk. When you start zooming it, exploring the Google Earth, you start getting the data on your display only, unless you go and save it. But it saves only the screenshot, it doesn't save the original data. But it allows us to study all parts, almost all part of the Earth on your desktop with coarse resolution to high resolution, and not only that satellite images but elevation value. So you can use, you can create or you can see, not create, it is already created. So you can see the many part of the Earth in 3D, especially mountainous terrain like this part is shown here. Glaciated terrain also you can see, cities you can also see, and many cities or buildings have now been mapped in true 3D. So you can have even walk-through kind of views on Google Earth. So most the world's most detailed globe, as it is said, is the Google Earth is, and it is I should say it's a wonderful product which scientists, civil engineers, earth scientists can really exploit, and this can be complementary to what we do in the field. So before going in the field, we can have the idea about the part or the terrain, the conditions, and the land cover, land use of that area where we are going to do some field investigations. So in that way, Google Earth is definitely very, very useful. Now this program can be, as I have said, also it can be downloaded on a smartphone or tablet, though it becomes very slow. The keyhole markup language, that is KML, and you can add your own data by converting your own data into KML or KMLE or zipped file, and then add those files in your already installed Google Earth and can see your own data on the Google Earth as well. So it shows the, as I have already mentioned, that various kinds of images which are overlaid on the surface of the Earth through this Google Earth, and say basically also having a web map service client also. That means if somebody is looking for a high resolution data sets to buy, to that extent you can get the scene indices of different high resolution satellite images, and then you can order those data sets to those companies who supply the data. So that is why it is web map service client also. That kind of detailed information, otherwise earlier we used to have index, scene index map of say Landsat or other IRS and other satellites, and based on those index map we used to identify the scene indices, and then we used to order the data. Now everything has been organized on Google Earth, not only for Landsat or IRS, but almost many satellites which are having high spatial resolution satellite images, and those things can, the scene indices, details, date of the scene, everything can be noted and then can be ordered. Google has also very importantly, this I like this part of the Google Earth most, is the historical imagery or available or archive, and which is available since 1972. That means from the first Landsat MSS. MSS is of course a scanner or sensor. So MSS images since 1972 onward are available in the archive, and this makes last for this 45 years of data, more than 45 years of data, allows us to study, to do lot of change detection studies. Be it may be related with water bodies, it may be related with vegetation, changes in landforms, and so on and so forth. So, this archive of huge number of big data of these satellite images, especially from Landsat series, have allowed us to use Google Earth for change detection studies. So, you do not have to do the georeferencing of all those scenes, anything, just move that cursor backward and forward and you get images of different dates or years on there. So, everything, there is a sort of stack of 20, 30, 40 images for almost all parts of the earth, and most of these images which have been put on Google Earth in this historical imagery are also cloud free, and you can choose the exact date, time, season, and can get the those images on the moon and can see the changes which has occurred in those last 45, 46 years of time. When we see the Google Earth, I am showing here the screenshot of part of India, and when you choose the like India district boundary, so all districts boundaries are also shown here. So, political boundaries, that a layer is there. So, it is a custom design, basically it is a custom design GIS software which is not only having your digital elevation model in the background, but it is also having satellite images of various resolutions. It is also having archives of satellite images, as I mentioned 1972 onward. But apart from that, it is also having several other data sets which otherwise you have to search here and there and may not get as organized as on Google Earth. Like streams you can get political boundaries, you get these these are WRS, these are the schemes or index maps for different satellites also, and various such layers you get here. These layers are there, and you can add your own layers as well. That is the biggest advantage, one of the biggest advantage of Google Earth, that you too can add your own data sets. You can share your data set with others also. Otherwise, on your desktop machine or on your machine, you can see your own data set along with other data set in Google Earth. So, it is a custom design GIS software with lot many facilities are there. Earlier when there were two products, Google Earth and Google Pro. Now, so Google Pro, you have to buy or pay some money to have access to Google Pro. But now later on Google Pro 2 has been made free of cost, so that makes us our very good for scientific uses, especially when you want to grab or save an image which is being displayed in the view of this Google Earth, and then Google Pro allows you to do that part, and a simple Google Earth was not allowing that part or that thing to do it on Google Earth. So, Google, whenever now you install Google Earth, install Google Earth Pro latest version, which is a 64-bit, very fast, and lot of data is available. If you go for high spatial resolution images, as you can see, this is IIT Roorkee campus is seen here. A very detailed map or satellite images you can see. The purpose here I was trying to show is about this archive. So, when you choose this option, which is a kind of winding clock, and when you move this cursor, you can see the images. This image of 13th May 2019, latest, more or less latest image at very high spatial resolution of IITR campus. If I move this cursor towards the left, then I can see the old images of the same part of the earth which I am currently displaying at the same scale. So you don't have to bother about georeferencing, you don't have to bother about change in scale. What you are seeing only the change in the images. You are going through the archives, and many images are available for say this part of the earth, and many, almost all parts of the 20, 30 such images are now available, and most of these images are cloud free. Of almost every season images are available. So for an Indian perspective, you are having images of summer, you are having images of monsoon period, cloud free of course, and images of winter, spring, all those images are there. So these archive and data can be accessed very easily with the, and of course apart from this earth navigation through Google Earth also provides series of other tools through desktop applications, and I have already mentioned about in the previous discussion about Google Mars and Google Moon, which are also available only through this installation. So when you choose this option here which is given, then you choose two other Google, and that means Google Earth and Google Mars and Moon are also available, and they are also available to view in the night sky as well. A flight simulator is also there, though it is a game, but it can be used for many scientific purposes, especially those who are using for UAVs or drones, planning and drone missions. First they can do that part on the Google simulator or Google Earth, plan everything, and then use these drones. So in that way that kind of training can be done on the Google Earth as well. And it is sometimes there were some issues related with the privacy and national security also. So some country protested or contested with Google Earth to remove very high resolution satellite images of certain part of the country. People made a complaint including India, and then Google Earth accommodated those things and got rid of very high resolution satellite images of those sensitive parts, so called sensitive part of the earth, and including of part of India also they removed. But if you go, and the interesting part is that the high resolution satellite images of some parts of India cannot be seen in India, but if you go in other countries, open the same product, you are able to see it. So this concern about national security and threat to privacy only within India, but not outside. So that's anyway the problem for the Google Earth or those who are related with this kind of assessment about privacy or threat and other things, but it is a wonderful product. The technology which was the core technology which was used or is being used in Google Earth was originally developed at intrinsic graphics, because it involves a lot of graphics is there. All these images are nothing but the graphics and your digital elevation models, and in late 90s this technology was developed, and of course since about more than 10 years now we are having Google Earth available to us, wonderful product in that way. As you know that Google Earth images or imageries are displayed on a digital globe, and which displays the planet surface using a single composite image from the far distance. So when we see from far from Earth, we see a complete one image. That means the seams within different scenes are not visible, but when as soon as we start going zooming it, then we start seeing different imageries of the same area, finer details, and sometimes we get seams, very visible seams because of the time and date difference between two adjacent scenes. So whenever we find this kind of situation, the best way to avoid this is either go little zoom out or zoom in, and if it is possible, which is still allowing us to cover your study area, then probably you may not see the seam, or go back little in the time that through the archive you may again can avoid these seams as well. Before the launch of NASA and USGS Landsat 8, Google basically relied mainly on the images up to satellite images up to Landsat 7, but of course these Landsat images are also now available, of course through Google Earth, but if you want the original data set to be downloaded, then there are other resources from where you can have these images of your study area. Very easily you can download, and that too is free of cost. So now Google Earth uses Landsat images to provide imagery at a higher quality and with greater frequency as compared to, if we compare with Landsat 1 or 2 with the Landsat MSS sensor. Here is the OLI and thematic mapper sensor, and of course it is having much better spatial resolution, and image quality is also better, and the frequency of data, that is the temporal resolution, is also good. As you can see, at certain scale, at certain zoom scale, you see that entire area which includes Haridwar, Roorkee is seen, but when you start zooming it, you get much more detailed images. So at this stage you might be seeing, maybe Landsat 15 meter resolution satellite images, but when you come to this zoom level, you might be seeing images at 1 meter resolution or 4 meter spatial resolution. So as you start zooming it in the Google Earth, the image will change, and you keep getting higher and higher spatial resolution images. And basically the images which are hosted on Google servers, which are contacted by applications. So when as soon as you open and select the area to study or see on your screen or display on a screen, these images start coming through internet on your screen, and resolutions varies from 15 meter to 15 centimeter, but this 15 meter in some sense is not true, because there are Landsat MSS images are available which has a resolution of about 79 meter or roughly 80 meter resolution. So resolution, spatial resolution varies from, you can say, from 80 meter to 15 centimeter. For a part of India or many parts of India, we do not have images for 15 centimeter resolution because of the issue which I have just discussed related with the privacy and security of the country. So those images have been requested by Google Earth to remove. However, even if it is 1 meter or 5 meter spatial resolution images are available, which are very good, and a lot of applications for lot of studies, those resolution images can still be used very reliably, successfully, very accurately. Of course, digital elevation model, it is there. Earlier it started with the 90 meter spatial resolution digital elevation model. Now it is having 30 meter SRTM digital elevation model in the background. When I was discussing about Google Earth or Google Mars, I mentioned that in Google Earth and Google Mars you can see the wear surface or terrain surface of these two bodies, Google Earth, Moon and Mars. But in case of Google Earth, you cannot see the bare surface. That means that only the terrain surface of Google Earth. Always this digital elevation model from SRTM is always in the background. So elevation values definitely you can get, but you do not see a shaded relief model or digital elevation model of the Earth without satellite image. That is my point was here. Google Earth has become as big resource for ground control points. I have already mentioned, in order to do the georeferencing of especially the high spatial resolution satellite images of our study area. So sometimes we do not have any other source of reliable ground control points, except we go in the field and collect through DGNSS. So instead of doing that thing, if we can rely on the GCPs which we can collect on Google Earth, then still we can perform a very high accurate georeferencing of high resolution satellite images implying Google Earth. Now the 3D buildings of many parts of the world are also included in Google Earth. As you can see that these red parts, entire USA, Canada and Mexico and a lot of countries of South America, Australia and entire Europe has been covered, and these cities buildings models are in 3D are available, and that is which is called photorealistic 3D imagery are available. So when you zoom it to that level, you start seeing a 3D perspective, and not only 3D perspective but 3D coverage or 3D buildings of those area. Unfortunately, part of China, India and Gulf countries, we do not have such 3D building models yet, but I am sure very soon we might be having. One example is shown here. This is what you see the 3D view of many buildings at a very high resolution. Individual cars can be seen. Even if you see very carefully, you can identify probably some humans when the data was being acquired at that time. If somebody would have been there, that can also be recorded. So very high resolution satellite images are there, very detailed information is available. Google Earth is also now integrated with the street view for some areas, not all areas. So if you are having 3D building coverage for those countries, again you are having these street view of those areas. And the advantage with this street view, which because it displays the 360-degree panoramic street level photographs. So of course these photographs are taken on the ground, and then they have been put through this display, and which provides us a 360 degree. So you can move your cursor and zoom in, zoom out, and can see all the surroundings in all sides. That means 360-degree panoramic street photos of select cities are there and surroundings. And these are very helpful, and these are basically currently we can say these are ultimate things of GIS remote sensing, that sitting anywhere on the globe we can see the complete 3D panoramic street level or can have a feeling of a street level perspective view of any part or many parts of these cities and their surroundings. These are very useful from a tourist point of view and others, but sometimes people misuse these informations. That is why many countries are not allowing Google Earth to have such a 360 panoramic views of the street. Of course, these, as I have mentioned, these photos are taken by cameras mounted on some vehicle automobiles, and then they collect these images at different scales and from many angles, and then they are integrated through Google Earth, and which are available there. One additional thing which you get, of course, on Google Moon and Mars, you do not have the water bodies, so you cannot have in the ocean part or that part in case of Moon or Mars. But in case of Google Earth, we are having Google Ocean, which allows user to zoom in, and whatever the the surface and subsurface information, that is the 3D bathymetry of the oceans, is also available to some extent, and which can allow us to study a lot of things in water and oceanographers as well. These are things which very useful for navigation in the water, and also many explorations also, that where is more depth is there, where is less depth, and all kinds of studies related with oceanography can be done from Google Ocean as well. So you don't have to do any extra installation, just start zooming in ocean or sea part of the earth and you start seeing all those details there. So in summary, that is also about Google Earth, Google Moon and Mars, that it was first released in 2005 and since it has attracted hundreds of millions of users worldwide. It's a wonderful product, custom designed GIS software, and it provides not only satellite images, not only the terrain surface or elevation values, but many informations, even 360-degree panoramic street view are possible, and has made a profound impact on both academia and industry. And people like whenever they go in the field before that, it is always better, it is always desirable to study that area through Google Earth, get a feeling of that one, and you can optimize your field work with the help of Google Earth. You can plan many things. I also mentioned that you can plan this drone missions and through this flight simulators on Google Earth, and many things can be done before really one venture in the field or on the ground. So it has really made a huge impact on the many studies which involves the surface of the earth as well as oceans, and has been intense and persistent over past decade. This impact has been of Google Earth, and Google Earth was mentioned in an average of 229 publications per year since 2009. So it is getting a lot of citations of Google Earth, because a lot of people are using Google Earth data for various kind of studies. Even if may not be, it is not a substitute for field work, no way. It can be complementary, it can allow us to plan the things, and many things you can plot on Google Earth, which you can just show as a location of your study area, or location of earthquake epicenters, or location of groundwater wells, location of buildings, future buildings, bridges, all kinds of things can be done, and these things can be shared with others. So you have to just send that link or a small file, KML file or KMLE file through net to somebody, through email to someone, and as soon as he will double click on that file, his Google Earth, if it is already installed on his machine, will open, and that data which you have supplied will be displayed on his screen. So that's a very good advantage to share the data, maps, images, anything which relates with the coordinates, earth coordinate system can be shared very easily. So largely, broadly we can say that impact of Google Earth has touched upon most scientific disciplines, including civil engineering, including earth sciences, in botanical research, geological research, all those, and natural disasters too, and urban planning, and this town planning people have started extensively. We have used from our own experience and working, we have used Google Earth images to study the development of landslides induced by a reservoir along at the the boundary of Terry Reservoir, because old images are there when reservoir was not there, and new images are there, and in between images are there. So you can see that at what time and how the landslide started developing, and how slowly a small debris fall and a very small landslide or indication of landslide was there, and later on those have become full-fledged landslides. So because of this archive available through Google Earth, you can study the development of any such changes which are happening on the surface of the earth. So there are lot of applications of Google Earth. Many new will come. People will because as it is getting enriched from data sets, and not only the images but 360-degree, 3D and many other layers are getting added into the Google Earth. Also GIS science, as I have said, this is custom designed GIS software. So, Google Earth has also largely concentrated in GIS science, remote sensing, geosciences, civil engineering, archaeology, in geography or geoscience education also, human geography, other things, people have started using Google Earth because it's it has got huge resource of information, data which is available there. And these also the 360-degree panoramic street view is also allowing us. Even tourists have started using. If I have to go in some new place and if these 360-degree panoramic views are available, I put the location and I start seeing the things. So, I can become familiar before I land there. I can become familiar of that part of the world, and I can save my time and even resources. So, a lot of things are being done. 3D bathymetry is also, I have already mentioned, that is also there. So, this brings to the end of this discussion about Google Moon, Google Mars, Google Earth, and lot of advantages associated with these products. So, this brings to the end of this discussion. Thank you very much.